I welcome you all for this lecture series on deep learning. In this lecture, we will briefly discuss about what is pooling and how it is being used in the CNN, convolution neural network. First, we will see what is the purpose of learning this pooling in CNN. The purpose of pooling in a convolution neural network is to reduce the size of future maps while keeping important information. It helps decrease the number of parameters and computations, making the model more efficient. Pooling provides spatial invariance, allowing the convolution neural network to detect features regardless of their position. It prevents overfitting by summarizing future responses and reducing data complexity. Overall, pooling helps the convolution neural network learn robust and generalized representations for image recognition tasks. First, we'll see what is pooling in CNN, that is convolution neural networks. Pooling is an essential operation in convolution neural networks that reduces the spatial dimensions of future maps while retaining the most important information. After convolution, it extracts the features such as edges, textures, and shapes. Pooling summarizes these features so that the network does not become overly sensitive to exact pixel positions. By reducing width and the height of the feature maps, pooling decreases computational cost, preserves key patterns, and makes the network more robust to small shifts, that means small changes, or distortions in the input image. So if there is any distortions in the image, what it will do is it will provide these small changes, the small shifts or distortions in the input image. It makes the networks more robust. This means even if an image moves slightly in the that is moves slightly in the image, the CNN convolution neural network can still recognize it. So, for example, if I'm having the image, on image I'm having it, some cat or rat or any animal images, it is the image. Let us assume that it may be a shaky one, but if you are using this technique, you can be able to identify this is a circle like that. So if the small shift or anything had happened, we can able to identify, we can able to recognize it. Why we should go for pooling? The necessity of studying pooling. Pooling plays a crucial role in simplifying feature representations and improving learning efficiency. It reduces the number of parameters and the amount of computation required in deeper layers, making the network faster and easier to train. Pooling also helps prevent overfitting. This is the main advantages of using it. Reduces the overfitting, avoids the overfitting. So first, the pooling also helps the overfitting by removing minor variations and focusing only on dominant features. This means what will happen over fitting occurs mean it removes the minor variations and focusing only on dominant features. Moreover, pooling introduces translation invariance. It introduces the translation invariance, meaning the model maintains recognition ability even if an image shifts slightly in position. Overall, pooling strengthens the network strengthens the network's ability to generalize well to new unseen data. Next, the types of pooling. There are various types of poolings are available. Several types of poolings used in the convolution neural networks, each serving a different purpose. Each will have their own advantages. Max pooling selects the highest, that means maximum, highest activation in a region, highlighting strong or important features. Average pooling, if you are taking the average pooling, It takes the mean of the values in the region, producing smoother feature maps and reflecting the general presence of feature rather than strongest response. So it is being used for the strongest feature. It will gives us the smoother feature. Next one is the global pooling, such as global average, entire image. If you are taking the entire thing, we are going to take the average. This will see an example. So, such as global pooling reduces each feature map to a single value and is commonly used before classification layers to significantly reduce number of parameters. Choosing the correct pooling type depends on the nature of the task and how much detail needs to be preserved. We'll see one by one. The first different types, how you are going to choose means can be chosen based on the task requirements. Next, the if you are taking, this is the example. See here, maximum pooling means if this is the stride size is 2 cross 2. If I am taking, you can see it in this animation 3207. In this, what is the maximum value? Here we have to, the final answer should be 2 cross 2. We have taken only 2 cross 2 kernel. So the first part is the maximum value is 7. So in this case, the maximum value is 3. Here we are getting, and in this part, if you are applying the kernel, we are getting 9. And in this case, both 3 and 3. So 3 only we are getting. So in this way, the maximum value will be taking into account. And average pooling, if you are taking this part, kernel 2 cross 2, if I am considering the average, how we are going to take 3 plus 2 plus 0 plus 7 divided by 4. So 5 plus 7 is 12 divided by 4 is equal to 3. So we are getting 3 here. Here 1 plus 3, all other values are 0 plus 0 plus 0. So 4 divided by 4, the value is 1 here. And 5 to 9, 0, 9, 7 plus 9, 16. So 16 divided by 4 is equal to 4. And here 3 plus 3, 6 plus 2, 8, 8 plus 0. So 8 plus 0 is 8 divided by 4. Here 2. So in this way, we are finding out the average pooling. If you are applying, you will get the value like this. So it will calculate the average value from the area covered by the kernel. And here what it will do is they take the highest value from the, so the name itself, we can take the highest value from the area covered by the kernel, 2 cross 2 kernel. And the next one is the global average. What I have told you, entire all the values we have to add it 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So all the summation of all values divided by 16. So we are getting 8.5. Here the no concepts of windows we are using it. We are going to take the values of all, average of all values in this matrix. So in this way we are finding out the global average value. So we'll see one by one. The max, what I've said is it selects the maximum pooling, extracts the most dominant feature, that means strongest feature in each region by selecting the maximum activation value that I have shown to you in the previous slide. So here the maximum value only we are going to take into account. And next one is this is very effective and strong responses represents the important patterns such as edges and corners. Edges and corners. By focusing on the strongest signal, maximum pooling maintains a salient features while discarding weaker, less useful information. This also makes the network less sensitive to noise and small pixel variations. Because it preserves high response, it because response areas effectively, maximum pooling is widely used in most CNN architecture for classification tasks. Classification architectures for classification task will be using it. The next one is the average pooling. So in this case, the average pooling computes the, as I've said, what it will do, average pooling computes the average values of the pixels within each region unlike max pooling, which focuses on the single strongest feature. So, single strongest feature means if I have the kernel, if I am taking 0, 7, 4, 3, so max pooling, what it will do, it will concentrate only on the strongest value. This average pooling considers the overall presence of the feature across the region. So 7 only in the max pooling will take, but in the average pooling 4 plus 3, 7 plus 7 divided by 4. So 14 divided by 4. So in this way we will be finding the overall presence of the feature across the region. This creates the smoother, more generalized feature maps. It is especially useful when texture or distributed features, if you are using it, needed to be captured. However, because it smoothens the value, detailed or sharp features may become less prominent. Therefore, average pooling is typically used in applications where fine details are less important than overall features presence. So sharpen features, if it is not required, we will go for this type of pooling. Next one is global feature, global pooling. So we have considered the entire image, if it is a 16 cross 16 or 18 cross 18 or anything 4 cross 4, entire image, you have to take all the values, you have to sum up divided by how many grids are there. So we have to find out the average. Global pooling reduces the entire feature map into a single numerical, only one value alone we are getting. In the previous cases, max and minimum, based on the kernel, we are going to get the value. For example, global average pooling computes the mean across whole feature maps. Whole feature maps. This is often used at the end of CNN architecture. So end of the architecture only we have been using this, resulting in a drastic reduction of parameter and improved generalization. Global pooling ensures that final classification decision is influenced by features across the image rather than one specific region, making the model more robust and less likely to overfit. So it improves the model generalization and reduces the overfitting. Next, pooling window and stride. What I've said in the previous case, in the previous example, stride plays a vital role. Here, the pooling uses the window and stride, windows and it uses the windows and stride to determine how the feature map is downsampled. The window size, if you are taking 2 cross 2 or 3 cross 3, defines the region that will be summarized. Will be summarized, while the stride controls the how far the window moves each time. For example, the previous animation we have seen. For example, using 2 cross 2 window with a stride of 2 reduces the feature map size by half. Larger stride produces the faster downsampling, but too large stride can remove too much details. The choice of window and stride affects the balance between resolution and efficiency, making parameter selection an important region detection, and also it helps the how aggressively the feature map is reduced. Next, effects of pooling. This is all we should know. Pooling has a strong impact on how spatial information is retained in convolution neural networks. By reducing resolution, it forces deeper layers to learn high level concepts instead of focusing on small details. This helps in recognizing objects even when their exact shapes vary. However, if pooling is applied to aggressively, important fine-grained patterns may be lost, which can affect performance in tasks requiring precise localization such as segmentation. Therefore, pooling must be used thoroughly depending on the problem type. Based on the problem type only, we are going to take into account. So, excessive pooling may remove the useful fine details. So, the overly, if you are using the pooling, more details will be lost. And pooling versus convolution. What is the difference between the pooling versus convolution? Convolution and pooling, they serve different, but computationally the roles in both are roles in the convolution neural network. Convolution learns features by applying trainable filters that detects parameters such as it detects parameters edges and textures, etc. Pooling, on the other hand, if you are taking, in this case, the pooling, how we are going to differentiate from the convolution in the sense, on the other hand, summarizes these learned features and reduces the spatial resolution without using any trainable parameter. Here we have to use a trained parameter. Here we are using without any trained parameters. And convolution increases the representation power of network, while pooling controls the complexity and improves the robustness. Together they allow convolution neural network to build a rich hierarchical feature representations while maintaining efficiency. Next. So coming into so the main applications we should know before going into the convolution of the CNN are, the pooling in CNN has many important applications across various domains. So it is widely used in image classification, where it helps recognize objects efficiently by summarizing key spatial features. In face recognition system, if you are taking, pooling ensures that the model can identify faces accurately even when there are changes in lighting, angle, or expression. Say, for example, if you are using the impressions every day, if you are going as a attendant, going to the office and making a attendance, whether you are present or not, if you are showing your face, whatever may be the condition, whether it is a lightning or a dark space or angle, any angles, if you are tilting and if you are varying your expressions, it will be giving you the correct identification. In medical image analysis, it plays a vital role in detecting critical patterns such as tumors, tissue abnormalities by focusing on the most significant visual details. Additionally, pooling is used in object detection and image segmentation to extract meaningful spatial informations and enabling that is convolution neural networks. So coming to the here. So if you are taking into the additional the informations, if you want to look into object detection and image segmentation to extract meaningful spatial informations and enabling CNN to understand and label different parts of an image. So the first, image classification. Next, it is being used in the image face recognition systems and medical image analysis. It aids detecting the patterns like tumors or abnormalities, and it is also used in the object detection, and the segmentation is used to extract the meaningful spatial feature images, that is features from the images. So coming into the conclusion, and pooling is a key operation in convolution neural network that helps reduce feature map size, lower computational load, improve generalization, and provide robustness to small spatial variations. And the maximum pooling preserves the strongest features. Average pooling smooths the generalized information, and global pooling simplifies the network. The global pooling simplifies the network before classification. By carefully selecting pooling strategies based on the application, convolution neural network can achieve both high performance and efficient computation. Mainly, it prevents the overfitting. So in this way, pooling is used in the various applications what I've shown to you: image classification, face recognition, medical image analysis, and object detection. Hope everyone understood about this concepts of pooling in convolution neural network. The remaining things we'll discuss in the next lecture. Thank you.